Hey, welcome back. In this video, together with you, I want to finally understand how AI works under the hood. I want to share a simple explanation that will give you a general knowledge of the topic. By the end of the video, you will know what's exactly happening when you type a prompt into something like ChatGPT and it starts talking to you back. I divided my presentation into 5 different blocks, so we will take it step by step. Let's go. So, AI is just a pattern prediction, not a brain. Just imagine you type into your friend on the phone, do you want to go to there? And the phone suggests you 3 words, beach, gym and mall. Now scale it to a brain made of math that does this, not for the 3 words, but the whole paragraphs, images, code, audio, everything. That's basically how modern AI works. It's not some thoughts, feelings, or secret conscious. It's just gigantic computer powers plus ridiculous amount of data to learn from. So I want to strip away the sci-fi vibe and show you the simple core idea. AI is a pattern machine that predicts what comes next. When people say AI today, most of the time they mean machine learning. And machine learning, as you can see, is a way to make computers learn patterns from data instead of being explicitly programmed line by line by some developers. And for example, specifically tools like ChatGPT, they are a neural network. And neural network is a big stack of just math functions that takes numbers in from you and transform them and produce numbers out, like an answer for you. At the highest level, here's what's going on. We feed AI a ton of examples from the real world, like texts, images, code, etc. It looks for patterns in these examples. Later, when we give it a new input, it uses those patterns to predict a useful output. For a text model like ChatGPT's, the job is like, given the text so far, what is the most likely next token? And the token is, it's a small chunk of text, often a word or a part, or even whole phrase. So as you can see on this example, text placeholder, we have 95 tokens and 444 characters in this. So for example, if we type a prompt in ChatGPT, explain gravity like M5, the model is not thinking about gravity. It's predicting token by token what a good answer to this kind of request usually looks like based on what it has seen before. And it is important part, based on what it has seen before. So the magic feeling comes from scale here. Or for example, for companies like OpenAI that have ChatGPT, they have huge amounts of data, they have huge models, and they have fast hardware, obviously. But the core idea of this whole blog is AI learns patterns and it predicts what comes next based on these patterns. Now inside the neural network, numbers in and numbers out. Let's pretend we can freeze the time and slice AI model in half. What would we see inside of it? Not tiny robots, obviously, and not little brains arguing, just numbers. Rows and rows of numbers called parameters. And parameter is just a number inside the model that it can adjust while learning. These numbers control how strongly different inputs influence the output. So the output is the answer that AI gives you. In this part, we will open the blue box a little bit more, how a neural network turns text into numbers, mixes them around, and turns them back into words. So when you type something to AI, the neural network starts working. And step 1 is turn words into numbers. Computers only work with numbers, so the model turns each token into a vector. And the vector is a list of numbers that represents something like a word or in mathematical space. You can imagine each word becoming a point in a huge invisible space, where similar words are closer together. For example, dog and a cat might end up closer than a dog and philosophy. Coming on step 2 is pass these numbers through layers. And the layer is a new word here. Layer is a one step where the model takes input numbers, multiplies and add them with its parameters, and passes the result forward to the next layers. Each layer does roughly this. Takes the current numbers, mixes them using its parameters, weights for example, apply a simple nonlinear function. And nonlinear functions is a math function that lets the model capture complex shapes and patterns, not just straight lines. Well, it's a bit complicated, and in reality, we don't need it to understand what is it. It's just math. After that, as we apply simple nonlinear functions, we send the results on the next layer and next layer. It's all depends on the neural network, how many layers it has. So it's different for every neural network. After that, you can think of each layer as a group of virtual detectors. Early layers might detect simple things like this word looks like a name, and later layers detect more abstract stuff, like this whole sentence sounds like a question about physics. Later, it goes to step number 3, turn the final numbers into the next word. At the end of these layers, the model has some final numbers that represent what it thinks about the next token. You can imagine it like this. The model has a big list of tokens, of all tokens it knows. It calls vocabulary. For each token, it gives a score. How much does these tokens fit here? And the scores turns into probabilities. And probabilities how likely each token is to be the next one, from 0 to 1. I hope you understand how it works. It's a little bit complicated and strange, but the model picks one token based on those probabilities. That token is added to the text, and the whole process repeats to the next token. So, in short, words, it turns into numbers. It goes through many layers of math. It turns into scores, and the neural network picks the text for these numbers and pick the next word and do the same again for this word. So it's like a continuous process before it analyzes all the prompt that you send to it. How AI learns: training, loss, and nudging millions of knobs. Here's the part that feels like sorcery. How does this giant pile of numbers learn anything? Imagine an audio mixer with not 20 sliders, but 100 billion sliders. Training an AI is like automatically nudging all of these sliders millions of times until the output sounds right. The trick is that we don't hand tune those sliders. The model tunes itself by making mistakes and then slightly correcting the numbers over and over. So the training happens in 3 basic steps. Show the model an example. Let it make a prediction. So it think what are you typing? And measure how wrong it was, and gently push the parameters in a direction that should make it less wrong next time. So it think what's happening, why I'm wrong. To measure how wrong it was, we use a loss function. And a loss function is a formula that gives a single number representing how bad the model's prediction was. Then comes gradient descent, and it's a method for adjusting parameters by following the steepest downhill slope of the loss. So the step-by-step guide here is: compute the gradient. Gradient is information about how changing each parameter would increase or decrease the loss. Move each parameter a tiny step in the direction that reduces the loss, and repeat this action across billions of examples. This is why AI training needs so much compute. We are doing massive matrix multiplications for huge batches of data with many layers over many passes through the dataset. So that's where GPUs and TPUs comes in handy. So GPU as you all probably know, it's a graphic processing unit, chips that can do many math operations in parallel. So it's just video cards on your computers. And TPU is a tensor processing unit, special chips designed just for this kind of math, developed by Google, by the way, for neural network machine learning specifically. And overall structure of learning we can put like this: try a prediction, check the errors, slightly adjust millions or billions of numbers, repeat until it's good enough, and when it's good enough, you give the answer to the user. What happens when you type prompt into ChatGPT? Let's follow your prompt on its journey. You type, write a story about a robot learning to cook. Hit enter, a second later a story appears. What happened in that second isn't the model thinking about robots and cooking. It's running a very fast simulation of what text usually comes after a sentence like this, according to everything I've seen before. In this blog, I want to walk through that moment step by step. Here is what roughly happens when you send the prompt. The first step is tokenization. We talked about before. It's splitting your text into tokens. The model understands. Your sentence is broken into tokens. Sometimes that's whole words, sometimes smaller chunks like cook and ing. The next step is embedding. It's mapping each token into a vector of numbers. Each token becomes a vector that captures its meaning and context. The third step is passing through the model. Those vectors go through all the layers we talked about. For language models, there is often a transformer architecture, and in this case, transformer is a type of neural network that can look at all the words in a sentence at once and decide which one matters most using a mechanism called attention. Here in attention step, this is a mechanism that lets the model focus more on certain tokens when processing another token. When predicting the next word, the model can pay extra attention to robot and cook because they are important to the story. And the last step is output probabilities. Pick token and repeat. The model outputs a probability distribution over possible next tokens. The system then chooses one token based on those probabilities and a sampling strategy. In this case, sampling is the rule for choosing tokens. For example, always pick the most likely, or sometimes pick a slightly less likely one to keep it creative. Then it appends the token to the text and repeats the whole process to generate the next one. This loop continues until it hits a max length, or it predicts a special stop token, or the app decides, okay, that's enough, that's the answer for the user prompt. From your side, it feels like a smooth stream of text. Under the hood, it is just a tight loop of predict next token, add it, repeat. What AI can do and why it hallucinates. Let's talk about the part that nobody likes to admit. AI confidently saying nonsense. You ask about a book that doesn't exist, it invents one. Why does it happen? Is the model lying? Not really. Doing the only thing it knows how to do. Predict what text looks like it should come next, even when the real world facts are missing. Because language models are trained to predict the next token, they optimize to plausibility, not the truth. If the training data rarely says, I don't know, the model doesn't learn to say that often either. It learns to keep going and produce something that sounds like a good answer. When the model hallucinates, so when AI produces output that sounds confident but is factually wrong or completely made up, it's usually because the data AI saw during training didn't have the exact fact that you are asking for. And the pattern make up a reasonable sounding answer fits better than refuse to answer based on what it has seen. Also, AI doesn't have real-world understanding, long-term memory of previous conversations, unless a system is built around it to store it, like we have right now in ChatGPT. Goals or intentions, unless humans wrap it in a system that gives it those. It's a statistical model that we can use in larger system. And statistical model is a mathematical object that captures pattern data. Those systems can be very powerful and also very risky if used carelessly. But the core engine is still just input numbers, do math, and output numbers. That's why we still need human supervision, external tools to check facts, clear rules around safety and ethics. AI is a strong tool, but not a magic brain. So, to recap everything that we learned today, AI learns patterns from the data that we give to it. Neural networks are just math layers adjusting billions of parameters. Training is pushing these numbers downhill to the loss function until the models get good at predicting. When you type a prompt, it's just predicting a tiny token one at a time. It's powerful, but it's definitely not a person, and it definitely makes mistakes. If this helped you to build a clear mental image of what's going on inside AI, please leave a comment with your feedback. We will keep learning about them together in future videos. Thanks for exploring this with me, and I'll see you in the next one.